today we're going to solve trig equations. It's lesson 6, so we're jumping from 7.2 to 7.6. So again, we're going to be solving these again over the interval of 0 to 360 or 0 to 2 pi. Notice the parentheses around the 360 and the 2 pi, meaning I don't want to see 360 or 2 pi as an answer. Now, what we're going to be doing here is solving for x, or whatever variable is in our equation. So the first thing I need to do is get my x's together. Now, common mistake here, and let me show you the common mistake before I show you how to solve this, is students are going to think that all I have to do here is divide both sides by sign. Divide them by sine x, and that's going to give me tan x equals 1. This would only give me one of the answers. This is the wrong way to do this one. So what we need to do is we need to set our equation equal to 0. So I need to move the sine x to the other side. So I'm going to subtract it. I'm setting my equation equal to 0. And now I'm going to factor out a greatest common factor. My greatest common factor here is going to be sine x. So I'll divide this one by sine x, this one by sine x. So I'll write the GCF on the outside. And then in the parentheses is what remains after I divide. And now I set each of my factors equal to 0. So I'm going to set sine x, the GCF, equal to 0. See how by not doing it the other, if I did it the other way, I would lose out on this answer. And then I'm going to take the tan x minus 1, set that equal to 0, solve for x, so tan x equals 1. So now my two solutions, this is what we did in the previous chapter. Now, when we go to test and quiz on this, and even when you're doing the homework, make sure you're reading how I want the answers written. You're either going to give your answers in radians or in degrees. I'm going to do it both ways. I'm going to give both answers. I'm first going to, and this is where we're going to pull in our unit circle. However, whenever we see sign equals 0 or undefined, that's going to come from the points here. 1, 2, 3, 4. So 1, comma 0. 0, comma 1, negative 1, comma 0, and 0, comma negative 1. So remember, sign is y, so I'm looking to see where y equals 0, and I can see that it's going to occur right here and right here. And recall that those angles are either 0 and 360 or 0 and 2 pi on this side, and then pi and 180. Now, so the answer to this problem is both 0 and 180. I do not want 2 pi because up here, I'm only looking for answers that go up to 360 and 2 pi, but not include them. So the answer for sine of 0 is, when sine x equals 0, is going to be 0 and 180 if it's in degrees, or 0 radians and pi radians. So if they say give your answer in degrees, this would be the answer. If it says give it in radians, then that's the answer. Now I also have to do tan x equals 1. I told you back in chapter 5 to memorize that the tangent of 45 is 1. So that should be a clue here. So I'm going to do my all students take calculus. All students take calculus. You can either use your unit circle or you can do the triangle. You can draw your triangle. If you memorize that your reference angle here is 45, then to find the other angles, let's go ahead and figure out where tangent's positive. So I know tangent's positive here and here. And remember, to get this angle, I'm going to do 180 plus 45, and that gives me 225. So my two answers here in degrees for tangent x equals 1 is 45 and 225. And then if you look at your unit circle, the equivalent radian for this is pi over 4 and 5 pi over 4. So if it says give it in degrees, you say this. If it says give it in radians, then that's your answer. So once you realize that 45 is pi over 4, remember to get here, you're going to do pi minus the reference angle, or plus the reference angle. You would need to find a common denominator. Common denominator would be 4. So I could make this 4 pi over 4, add it to the pi over 4, and that's how I can get it to this if I didn't have a picture of the unit circle. Again, memorize that the tangent of 45 equals 1. You're either going to do the graphs, or you could do your all students take calculus. Once you find the reference angle, then from there find the other ones. Remember, when you're looking for the measure in quadrant 2, up here this would be pi minus the reference angle, or 180 minus the reference angle. And then down here, this would be 2 pi minus the reference angle, or 360 minus the reference angle. So once we solve our equation, then we're going back to all the skills that we learned in Chapter 5 and Chapter 6. Notice we have a trinomial here. So I'm going to factor this. So my two binomials that I'm going to create, I'm looking for the factors of tangent squared, so that's just going to be a tan x and a tan x. And now I also need to put in the factors of -2. That will give me 1. So that's going to give me +2, because my middle sign is positive, and -1. Once I have the two factors, the two binomials, you set them equal to 0. And now solve them. Subtract 2, tan x equals -2, add 1, tangent of x equals 1. Now, the tangent x equaling -2, this we cannot find on the unit circle. So what we're going to have to do here is our calculator. So remember, whenever you're looking for an angle measure, we're going to do the shift key or the second key. Okay, so what you're going to do here for this one is we're going to hit the second key or the shift key, and it's going to open up tan -1 because we want an angle measure. In order to get the reference angle in quadrant 1, I'm going to enter this as a +2. Once I do that, I'm going to get approximately 1.1. Let me go ahead and add in my all students take calculus. I want to know where tangent is negative, so I can cross off here and here. So I'm going to take this reference angle of 1.1. This is in radians. So now what I'm going to do is I'm going to do pi minus 1.1, and for quadrant 4, 2 pi minus 1.1. This is going to give me 2.04. So I'm just going to round it to 2. And then this one is going to give me 5.2. So in radians, it's 2 and 5.2. Over here, again, tangent of x equals 1. Again, that tells me it's my 45-degree reference angle. So pi over 4. And then all students take calculus, tangent positive. So it's the 5 pi over 4 again. So x equals pi over 4 and 5 pi over 4. Oh, it's kind of... All right, so here I've got a radical in my equation. Yes. So let me rewrite this problem down here. So tangent x plus root 3 equals secant x. So what I need to do here to get rid of that radical is I'm going to square both sides of my equation. So I'm going to end up foiling this, tan x plus root 3, tan x plus root 3. So when I FOIL this, I get tangent squared x plus tan x root 3 plus tan x root 3 plus 3. And then I still have the secant squared x now. I can combine the middles. Now, if you memorize the pattern, just always know that you're going to square this, and then this times 2 is the middle. So plus 2 square root 3, I'm going to pull it around the front, tangent x plus 3 equals secant squared x.
Can you convert that to the tan x?
Yes. So I am going to pull this in, and I am going to change secant squared into its Pythagorean identity, and I'm going to change this into 1 plus tangent squared x. I'm going to rewrite the other side. So tangent squared x plus 2 radical 3 tan x plus 3. I now need to try to get my x's on one side and my numbers, everything else on the other side. So when I go to try to get my tan squared x's together, notice that they're going to cancel. So then I have 2 root 3 tangent x plus 3 equals 1. I'm going to move the 3 over. And then I'm going to divide both sides by 2 square root 3. So tangent of x is equal to negative 2 over 2 square root 3. I'm going to rationalize. So the 2's will cancel. They'll become 1's. And then I have to multiply top and bottom by root 3. So then this becomes negative root 3 over 3, and there's that answer. So now I'm going to go to my unit circle, and I have to figure out which angle gives me negative root 3 over 3 when I divide y by x. So, and again, you're going to do your all students take calculus. We want tangent to be negative, so get rid of this and this. And then I'm going to look at my unit circle and figure out when I do y divided by x, which one gives me this. And that's going to be 5 pi over 6 and 11 pi over 6. So again, we're pulling back all the stuff that we've just done and just tested on in chapters 5 and 6. Now, remember back in chapter 6, I had the file that had all those tan answers. So if you memorize which order pair gives you this answer, then all you have to do is look for it. Clue would be as soon as you can narrow down the quadrants, look for the same denominators. Whenever you have a radical, we need to check our answer for extraneous solutions. So I need to check this, and I need to plug it back in to the original. So when you have a radical, we need to check our answers. So let me rewrite the original problem. Tan x plus root 3 equals secant x. And I'm going to write it both 2 times because I got 2 things to plug in. Okay, so I'm going to plug in first the 5 pi over 6 here, and then the 11 pi over 6 here. It's going to go into both of these. So I'm going to do tangent of 5 pi over 6 plus root 3 equals secant of 5 pi over 6. So if you realize that this is in your second quadrant, we're going to go over, find 5 pi over 6. We're going to divide y by x, and it's going to give us negative root 3 over 3. Over here, secant of 5 pi over 6, I'm going to flip it to the reciprocal, and you know secant looks at x, so it would normally be root 3 over 2, but I'm going to flip it. So what I'm going to put here is negative 2 root 3, because again it's in the second quadrant, and I'm looking at sine. And now I need to simplify this to see if the two sides are equal. So here I need to find a common denominator. It's going to be 3. Whatever you multiply to the bottom, you're going to multiply to the top. So this one stays the same. It already has the 3. This one becomes 3 root 3 over 3. And then when I combine, I can assume a 1 there. And this becomes 2 root 3 over 3. Let's see. So this one does not work. Let me rationalize this side. So once I rationalize this side, I end up with negative 2 root 3 over 3. One side's negative, one side's positive. So this one doesn't work. Let's try the 11 pi over 6. So plug it in, tangent 11 pi over 6 plus root 3 equals secant 11 pi over 6. So I'm going to go figure out what the order pairs are for the 11 pi over 6. I'm going to divide y by x. So once I divide y by x for that angle of 11 pi over 6, I get negative root 3 over 3. And then here, secant, when it's in this quadrant, it's going to be positive. So 2 root 3. Again, you got to rationalize this. And then it becomes 2 root 3 over 3 positive. And over here, when I find a common denominator, and then add them, notice that both sides equal each other. So this one checks. So the only answer that works is the 11 pi over 6. So when you have a radical, you need to check your answers in your original problem. Let's try the next one. All right, so here I need to get my x's together and my numbers together. So I'm going to subtract secant x. And you could treat this as like 1 secant x. So 2 minus 1 is just secant x. Then I need to move the 1 over. So secant x equals 2. Remember, secant is the reciprocal of cosine. So if I flip this to the reciprocal, this is actually something on my unit circle. So I'm going to be looking to see where x equals 1/2. So let's go ahead and do your all students take calculus. So cosine's positive here and here. So I'm going to look for the x to be 1/2. And that's going to give me from my unit circle pi over 3. And then to find this one, you could either look for the same denominator on your unit circle, or you could do 2 pi minus pi over 3. Find a common denominator. 6 pi over 3 minus pi over 3 gives me 5 pi over 3. So x equals pi over 3, and 5 pi over 3. Now, if you'd rather go back and draw the triangles, you just have to figure out, is my reference angle 30 or 60? So again, opposite the 30 is 1. This guy's a root 3. This guy's 2. So then you could do, back what we did in chapter 5. You have different options here of doing these. Yeah. So again, when you're trying to find the other angles, over here is the reference angle. Up here you do pi minus the reference angle, pi plus the reference angle, and 2 pi minus the reference angle. Or if you're going to do it in degrees, still reference angle, but this is 180 minus the reference angle, 180 plus the reference angle, or 360 minus the reference angle, depending on how it's asking. If they ask you to do this in degrees, pi over 3 is 60 degrees. So then here, when I go to do it, 360 minus 60, and the other angle, the 5 pi over 3, is the 300. So again, now that you memorized the unit circle for the last test, you're going to need the unit circle again for this test. So don't forget it. For example 5, it's already factored for you. So all you need to do is set each factor equal to 0. So here, cosecant x plus 2 equals 0. Cosecant x minus root 2 equals 0. I'm going to subtract 2. Cosecant x equals negative 2. Add the root 2. Cosecant x equals root 2. And from here, we're going to try to figure out where, as soon as I see square root 2, that's a clue to me that it's the 45. Here again, these are reciprocals. So really what I'm going to be looking at here is sine x, where it equals negative half. Over here, this tells me it's going to be the 45. So even if I flip it, sine x here, 1 over root 2, rationalize, root 2 over 2, I can find that on my unit circle. Again, remember for sine, we're looking at y. So you can do your all students take calculus, all students take calculus, all students take calculus. For sine negative, get rid of this and this. So I'm looking here and here. And over here, I want sine positive, so get rid, and now it's opposite. So I'm looking for a y ordered pair, or the y in the ordered pair, where it equals negative half in these two quadrants, and that's going to be 7 pi over 6 and 11 pi over 6 for this one. And then this one, I'm looking for root 2, which is the 45, so that should be a clue that it's the denominator of a 4. So pi over 4 and 3 pi over 4. All right. So for here, I'm going to make it into a trinomial. Again, you need to set it equal to 0. So I'm going to subtract the 1. So 2 cosine squared x minus cosine x minus 1 equals 0. I need to factor the trinomial. So I'm going to do it guessing and testing. I'm going to put a 2 cosine here and a 1 cosine here. And then I got to figure out where I put my negative sign for the 1. So I could put 1 and 1 here. Let's try to put a plus on that one. So when you FOIL this, you're double checking that outer and inner gives you negative 1. So when I do this one, I get negative 2 cosine x. And when I do this one, I get positive 1 cosine x. When I add them, I get the negative. So I put my signs in the right spot. So now I set each one equal to 0. So 2 cosine x plus 1 equals 0. And 1 cosine x minus 1 equals 0. Minus 1. 2 cosine x equals -1. Divide by 2. Cosine x equals -1/2. Over here, add 1. Cosine x equals 1. So cosine, remember, we're going to look at x. So I'm looking at my x order, the order pair in on the unit circle to see where x equals -1/2. Let's also do our all students take calculus. And here cosine is negative in these two. So again, I'm going to look where the x is -1/2, and that's going to be at 2 pi over 3 or 4 pi over 3. And again, in degrees, that's 120 and 240. Over here, this is going to come from, I'm looking for an x. Let's see on this one. No. We use the axis points, 0 and 1, -1, 0, 0, -1. So I'm looking to see where x equals 1, and the only place that that occurs is right here. So my answers, remember this is 0 and 2 pi, or 0 and 360. I don't want those, so my answer here is x equals 0 degrees and 0 radians. Maybe I should put it that way because I wrote the radians first. So that would be the answer there. Oops. All right, so here, tangent x minus 1 equals 0, cosine x minus 1 equals 0. Add 1. Tangent x equals 1. Oh, that should be a clue. That's 45. And then add 1. Cosine x equals 1. I just did this one on the previous slide. So you're going to start seeing patterns. You're going to see it repeat. So right away, you should realize that your reference angle here is 45, or pi over 4. So again, we want to do our all students take calculus. It's going to be positive in quadrants 1 and 3. So as soon as you see it's 45, you're going to say it's pi over 4 and 5 pi over 4. Or 45 and 225. For cosine, again, that's going to come from the axis points. So 1, 0. We're looking for x to be 1, and it's right here. So my angle here, in degrees, it's 0. In radians, it's 0. Do number 8. This one I'm going to use a Pythagorean identity. So I'm going to change this into, I'm going to use this identity, sine squared x plus cosine squared x equals 1. Subtract the cosine. Sine squared x equals 1 minus cosine squared x. So I'm going to take out this, and I'm going to put this in its place. So cosine squared x equals 1 minus cosine squared x plus 1. The plus 1 is still there. Pretty good?
Are there multiple ways to do these two?
We need to get like terms, so that's why I needed to change them into the same trig
I
function.
know, but could you make the cosine like 1 minus sine?
Yes.
That's-
Yeah. All right. So now I'm going to add the cosine. So I get 2 cosine squared x equals 2. Divide by 2. Cosine squared x equals 1. I need to square root both sides. So cosine x equals plus and minus 1. So I'm looking here to find out where x, because remember cosine looks at the x, so again my axis points. So I'm looking to see where it equals both plus and minus 1. And that's going to be the 0 and the pi. I don't want to list 2 pi as an answer because it's got parentheses around it. So x equals 0 and pi, or 0 degrees and 180 degrees. Just read the directions to see how it wants the answers, whether it's in degrees or if it's in radians. One more example. And it's already factored for us. So all we're going to do is set them equal to 0, because we could just put parentheses around it. So sine squared x equals 0. Cosine squared x equals 0. I need to square root both sides. So sine x equals 0. Cosine x equals 0. There's no plus and minus 0 here. So as soon as I see this, I know it's going to come from my axis points. Sine looks at y. Cosine looks at x. So let me go ahead and figure out where my order pairs are. So where y is 0, it's going to be at 1, 0, negative 1, 0. Again, I'm looking at the y, and it's here and here. So again, remember, this is 0 and 2 pi. This is pi. So my answers here are going to be 0 degrees and 180. Or 0 radians and pi radians for that one. And then here, cosine's looking at x. So I'm looking to see where x equals 0. And if I go ahead and add points here, it's going to be 0, 1, 0, negative 1. So again, I'm looking at the x to see where it's 0. And this is pi over 2. Or 90, and this one's 3 pi over 2, or 270. So this answer here, pi over 2, or 3 pi over 2, or 90 degrees, and 270 degrees. So homework is 17 through 35 odd. You're submitting it through Canvas just like normal. And then what's going to end up happening is, more than likely, I will have these answers worked out, and then you can check your answers. Either that or the ones that you're struggling with, you'll email me, and then those are the ones I'll post. We'll see how it's going to work out.